Hello everyone, welcome to Clashing Coders. So in this video we will see the question that is next larger element, or you can say next greater element. So this is a medium level question and you can see the accuracy is also quite good and the points for this question is also high. So that means this question is a important question and it has been also asked in various interviews, for you can see Amazon and Flipkart, etc. you can see, and sometimes in Google also. So let's see the problem statement and then I will explain you how we can solve this using naive approach, then the optimal approach. So let's see. Given an array A of size n having distinct elements, so that means all elements are unique. The task is to find the next greater element for each element of the array in order of their appearance in the array. So let's see what is next greater element. So next greater element of an element in the array is the nearest element on the right which is greater than the current element. So that means in this example you can see if we are trying to find the next greater element for this current element, you can see next greater element of an element. So the of an element is this one, and so the next greater element for this element will be the nearest element which is greater than the current element on the right side. So you can see at the right side of the 1, 3 is greater than 1 and 2 is also greater than 1 and 4 is also greater than 1, but the next greater element will be the nearest. You can see the nearest element, so it will be 3. So you can see in the output also it is 3, and you can see here if that does not exist. So for example you can see the rightmost element in this you can array, so it is 4. So 4 does not have any element which is right towards it, so it will not have any element next to the element, so we will simply print -1. So if the element here you can see if there is element 8, so you can see in this example 8 is here, but there is no element on the right side which is greater than 8, so here also we will print -1. So these are the two cases, and you can see for example for next greater element of the last element is always 1 and -1 as I told you. So we have to just complete this function. We are given this function and we have to write code here, so we don't have to take care of the driver code. So let's see. So you can see the expected time complexity for this will be O of n and O of n space complexity also, and the constraints are pretty much large. You can see not n, but you can see the elements is 10 raised to power 18. So int cannot store this bigger number, so we will have to use long. You can see they have used long. So let's see how we can solve this question, and I will also explain you the examples more clearly. So now you can see this is the example, and for this we have to return. Here you can see we have to return a vector which is long type, and we have to return the next greater element to every element. So you can see for this element 6, if you see, so 6 has a greater element. You can see this 8, so 8 is greater than 6, so that means it is towards the right side and also the nearest element to the 6. So 6 will have the next greater element as 8. So now for 8, if you see on the right side of the array, you can traverse here, so you can see there is no element which is greater than 8. So we'll simply print -1 or add -1 here because there is no element greater than 8. So you can see 0. So now 0 has two elements greater than 0. You can see 1 and 3, but out of them we will have to write the nearest element. So nearest element to the 6 which is on right side of 0 is 1, so we'll write 1 here. So now you can see 1, there is only one element left and which is also greater than 1, so it will be 3. So it will be 3. So now 3, the rightmost element always is has -1 as the next greater element, because it is you can see it is at the rightmost index, so there will be no element after that, so it will be simply -1. For this also you can simply write it as -1. So now you can see for 7, let's start from here only. So for 1 you can see 3 is greater, 2 is also, all the elements are greater from 1, but we will have to write the nearest. So nearest one will be 3. For 3 it will be, actually you can see 2 is not greater but 4 is greater, so 4 is nearest to 3, not 7, so we will write 4 here. For 2 the 4 is greater, so again 4. So now for 4 there are 7 and 5, but 7 is nearest, so it will be 7. So now for 7 there is no nearest element which is greater than 7, so it will be -1 only. You can see -1. So this is a simple example, and I hope you understood the example. So let's see the naive approach, how we can approach this question in an interview if you are asked. So let's see. So the naive approach for solving this question will be, as I told you, if we are on this element, just for example if I is here, so what we will do is we will traverse from I plus 1. So I plus 1, we are not comparing the current element, so we are using the current, we are trying to find the element which is greater than the current element. So j, or the second loop, will be start from the I plus 1. So it will start from I plus 1 and it will run till n. Okay, it will run till n. For current element it will keep checking if this element is smaller than the jth element. So you can see I have written the pseudocode. So first we will initialize a result array with -1. So why -1? Because as I told you, if the element is not having the next greater element, so it will simply have the output as -1. So why not simply initialize the array with -1 beforehand only? So we have initialized the array with -1, then we will traverse. You can see we will traverse the array. For every element we will try to find the maximum, next larger element for the particular element. So for doing that we will have to use another loop. So that is why it will take O of n square time. You can see this loop will run from j I plus 1. So it will run from the next element to the I, and it will check if a of I is less than a of j. Whenever we get the first element which is greater than this current I, so we will simply set the result I, that particular index, to the element that we have found which is greater, and simply break from the loop, because otherwise it will keep like traversing over the array. So it will change the next greater element, which will be wrong. So simply break that, and again I will come here. Now I will come here, then I will come here, then j will start from this point. So again it will traverse for these three elements for this particular I. So that is why it will, now this solution actually you can see we are using two for loops, so it will take O of n squared time, and the space complexity will vary, because if you are returning array, so you will simply, if you are returning array, you will have to use the vector to store it, so it will be taking O of n space. But if you are simply printing the elements, so then it will take O of 1 space. So let's see now how we can optimize this solution further. So let's see in this example. So in this example we will be using a stack. So why stack? Let's see. So stack is actually a data structure which has three operations actually. So first operation is push. So it is a last in first out. So that means that the element which is added first, okay, it will be down. So like the structure of this, you can see stack here. So if element is added at first, so it can be removed only after the elements which are added after it are removed. So that is why it is called last in first out. So how we will use stack here? Let's see. So if you see in this array, if we are traversing, okay, if we are traversing, what we will do is, these are the elements, okay, these are the elements, so we will add them into the stack. So when we add 6, okay, we add 6. So why we are using a stack, I will clear you now. You can see when we get 8, so when we get 8, next element we will traverse over the array, and we have stack, so we'll push every element to the stack one by one. You can see we have pushed 6. So now when we iterate over the next element, so 8 comes. So now when 8 comes, there will be a rule. So if the element that we are on is greater than the stack top, so stack top will return this element. So it will not pop this element, but return this element. So yeah, see, you can see the stack top 6 is less than 8. So when you are adding a current element which is greater than the element or top of the stacks, so this means we will have to pop this element. So you cannot add a element if the current element which is greater than the top element of the stack, so you cannot add that. So we will have to pop the 6. So why we are popping this 6 before adding 8? So while we are popping this, okay, 6 before adding 8, it means that we have found a element that is greater than the top of the stack. So that means for the top of the stack, that is 6. So okay, the element 6, we have found a next greater element which is nearest to it and also greater than it. So it will be 8 actually. You can see 8. So we will be having this result array. So when we pop 6, so we will actually not store this element, we will store the index. So we will store the index. So index is 0. So we will set a result of 0. So result of 0 is this through the current element which is greater than this element. So I will make you more clear. Let's see the algorithm actually. So I hope you got the basic approach. So let's see the algorithm. So this is a pseudocode actually. As I told you, we will have to use a stack. So first of all, we'll initialize a stack and the result array. So result array will have elements as set to -1. So you can simply use a vector in the C++, or you can run a for loop and set all the elements to -1. So this is the stack representation. So okay, I have made this stack. So you can see it is only open from the top side. So you can pop only elements from the top. And let's see. So first of all, as I told you, we will not push the elements actually directly. You can see here as it did. So we will actually push the indices. We will push the indices because we will have to set those indices in the result to the particular value that we have got. So we will use indices. So first of all, first element we have to push. So it is for sure we have to push the first element. So we will push simply the first element. So this will avoid one condition in the for loop. That is, if stack is empty, so we push the element. So it will avoid the condition. So we will simply push the 0. So 0 is actually, you can see 0 is this element, that is 10. So now when we start iterating, so it will start iterating from this point. So it has iterated at this point, you can see 8. So now you can see while not empty, stack is not empty. So yeah, this is also a function. If stack is not empty means it will return. If it is not empty, then only while loop will run. So you can see it will turn false, true, sorry, because stack is empty, it is false, and it is negation, so it will become true. While true and array of top. So you can see array of this array of astro top. So astro top is 0 and array of 0 is 10. If 0 is less than this 10 is less than 8, so it is not true. So that means we can simply add the element. So we can simply add the element. So this condition will not run because this is true, but this is not true. So this will not enter into this iteration will not enter into this condition. So we'll simply push the element. That is elements indices. That means 1. You can see 1 will be pushed. So why we push simply 1? Because you can see 10 was here. 10 in the index was here. So when we try to push 8, so 8 can simply be pushed because 8 is not greater than 10. If it would have been like 8 would have been came first, then it would have been 10. So then we will have to pop 8 because 8 has found its next greater element, so we will simply pop 8. But in this case it has no 10 is greater than 8, so we don't have to pop anything. So actually let me tell you, there are two rules, so let me write it them right here. If stack dot top is less than the current element, so we will simply as we will pop the elements. Okay, we will pop the elements, else we will simply push the element. Okay, if the element that we are adding is greater than the top element of the stack, we will simply pop till the element gets greater, the top element gets greater than the current element. Otherwise we will simply push the element. So in this case we simply push the element, we did this condition. So now when we come to this point, I comes to this point, okay, this point, so these actually are initialized with -1. Beforehand they are initialized with -1. Okay, they are -1 initially, all of them are -1. So nothing has happened till here. Now when we come to 0, so this element index 2, so we will check if the current element, so you can see while stack is not empty, so stack is not empty, and we will check array of astrotop. So astrotop is 1 and astrotop is 8. Okay, this array of astrotop is 8. Now you can see the current element that we are on is 0, so 8 is actually greater than 0. So now you can see this top element 8 is less than this current array. No, it is not true, so that means this condition will not run, this will be false. So we will simply push this element. So when we push this element, you can see the index is 2. So why we are simply pushing it? Because we know that this cannot be the greater element than this element, so nothing will happen, so we'll simply push it. So now when I comes to this point, you can see it has come to this point, and now we will check while stack is not empty. So yes, stack is not empty, it has 3 elements. So now you can see when we come to this point, that this index 3, so we will check the element of the 3. So we will check the top element, so that is 0. So this is the index, so a of 0, you can see array of 0, that's the top 0 is less than the current element, so 1. So 0 is less than 1, so that means we cannot simply add the 1. You can see if it is this, so we will simply pop the element. So what we will do, that means we have found for the 0 the second index, that is 0 element, we have found a next greater element. So before popping, what we will do is we will have a result array, so it will be initialized with -1 initially, as I told you. So at this point 0, so we will have the index of 0, so it will be, you can see astrotop, so astrotop is 2. So at this point result, this is our result array. Okay, this is result array, so we will set the result of this 2 to the element, current element, which is greater than the astrotop, so it will be 1. So that means we have found the next greater element for 0. You can see it is 2, so next greater element for 0, that is nearest to it is 1 only, so that is correct. So now we will simply push the element, because when we pop the element, so 0, this index is popped, so now we will push the index of the 1, that is 3. So 3 index is pushed. So now when we come to this point, you can see this 4th index and the element is 9. So again array of a stack is not empty, and the array of top, that is 3 index element 1 is less than 9, so we cannot push an element. So when an element in the stack, okay, top of the stack is less than the current element, so current element is 9, so then we simply cannot push the element, because for this element we have found the next greater element, that is 9. So we will simply pop it, and while if it has multiple elements, like if it has 0 1, so 0 and 1 both are smaller than 9, so that means both next greater element will be 9. So we'll simply set their next greater element to 9 and pop the both. So that is why we are using while loop, so it will run. Okay, so for 1 we have found the element, so 3 will be popped, so it will be, this index will be set to 9, this result result 3 will be set to 9, that means next greater element for this is 9. So now we again, this loop will run, because stack is not empty, it will check if stack dot top, so stack dot top is 1, so it is this 8, so value is 8, so 8 is again less than 9, the current element that we are on, so that means we will have to pop this index also. So we will set the next greater element of 8 to 9, because we have found the element which is greater than 8 and which is also nearest to 8, so you can see 9. So till now we have found these 3 elements, so these elements are popped, so let me erase them. So now we have only one element, so you can see this 10. So again this loop will run, but the stack is not empty, this condition is true. But if you check array of astrotop, so astrotop is 0, so 10 is not less than 9, so that means we can simply push the element, because you can see if the stack dot top is greater than the current element, so we cannot do anything, so we'll simply push that index, so it will be 4, so 4 will be pushed. So now when we come to this point, so let me erase all this mess, so let me erase it. So till this point we have found the values for, you can see this 3 elements which are confirmed. For the 10 we cannot say till the end of the array, so if it is it remains -1, that means we couldn't find the element which is greater than 10, otherwise we will update it. So let's see. So now when we are on this index, so we are on this index 5, so element of 5, that is 2, is, you can see, is not greater than 9, so stack is not empty, and this element, so the current element, that is 9, is not okay less than 2, So that means nothing will happen. So we will simply push this index. So when we push this index 5, so 5 index will be pushed. So that means the whole iteration, this for loop has run, but only these were set to -1. So only these 3 elements were able to find their next greater element. So let's check this out. So if our answer is correct or not. So you can see for 10 there is no element remaining which is greater than 10. So answer will be -1 here. For 8 the next greater element is 9. You can see 9 is greater. So for 0 it will be 1. For 1 it will be 9. So which is correct. For 9 there will be no element which is greater than 9 on the right side, so it will be simply -1. And the 2, which is the last element, it is always -1. So as I told you, we have already initialized the result array as -1, so we don't have to do anything for the other remaining elements which were not able to find the next greater element. So they are already set to -1. If you don't want to do this, what we can do is, for all the indices that are remaining in the stack, so you can simply run a loop. While stack is not empty, you can use this condition. While stack is not empty, you can set result as to top, which will be this element, to -1, all the elements to -1. So this will be simple approach for solving this question using a stack. So the time complexity for this approach will be O of n, because you are only traversing the stack this array one time, and while you are popping this element, so it will be approximately O of n time, and the space will be O of n. Again, this will be surely O of n because you are using a stack. So stack will have all the elements, so it will have to store the elements. So it will be using O of n space, and the time complexity, as I told you, will be O of n. So why we are storing indices here? As I told you, you need to remember that we are storing indices here. You can do also using the values, but it makes it easier to store the indices, because you can simply set the result of index to -1 or the value that you're getting. It will make your computation easy. So you can see in this case, so we are getting the long array. So this long we are using, so elements are long. So for that, if you try to store the long into the stack, so it will be wastage of memory. So if you store simply the indices, so it will be int only. So you can simply make a stack of int and store the indices. If you try to store the values long, so it will be of no use. It will actually use your memory. So if you it will be actually negligible, but you can compare it. So let's see the code actually for this solution, and I will also provide the code in the description. So you can see the code is this. So you can see, first we will simply initialize the stack. So you can see we have initialized the stack of integers, because we are going to store the indices in the stack, not the actual elements. So then we have to return the result array. So it will be of type, you can see long from here, and we will initialize it will be of size n only, the size of the array, and we will initialize it with -1. So in using the stl, you can simply write as this index. So then we will simply push the first element to first index, then we will traverse over the array, and then we will check if the stack.top is less than the current element. So we will set the result, that particular of the top element, to the current element, that is its next greater element. So then we will pop that element. Otherwise, if it is not so, at every step we will have to add the element, the current index element. So we will have to add that. So this condition will be always running, but this condition will be running only if the stack.top is less than current element. So it will push, it will pop the elements if the current element that is on the stack, this 5 is this index element is less than the next element that is here. So if, for example, here is 11, so it will pop that element. So simply it is doing that. Then we will simply return the result. So let's compile the solution, and let's submit it directly. So I will also provide the code in the description. I hope you got this solution. So let's see. So it is submitting. So guys, do make sure that you like this video and subscribe to the channel for more such videos. You can see it got submitted. So I will also provide the code in the description. So thank you for watching, guys.